Bismillahirrahmanirrahim. Today we are going to solve Cambridge IGCSE Physics Paper 4 Theory Extended version for the session of October-November 2023. We have the subject code 0625 and the variant is 52. We have 1 hour 15 minutes for this paper to solve, and the paper is carrying 80 marks. We need to use the value of 9.8 Newton that is given in the question paper. We are allowed to use calculator. We're gonna start our paper from the question number 1. Question number 1 is that a car accelerates uniformly in a straight line from rest okay at a time t is equal to 0 and at t is equal to 3.2 seconds. The speed of the car is 13 meter per second. Calculate the acceleration of the car. We know that acceleration is the rate of change of velocity. So we're going to calculate acceleration by this formula. Acceleration is change in velocity over change in time. So we are given by the velocity that is 13 meter per second, and we know that car is moving from the rest, so initial speed would be 0. Initial velocity we're going to take at 0. So change in velocity is 13 minus 0, and we have the change in time that is equal to 3.2 minus 0. We're going to simplify this 13 over 3.2. We're going to get the answer that is equal to 4.1 meter per second square. This is the unit of acceleration, so we're going to write over here 4.1 meter per second square, or you can write ms minus 2. Moving to this other part, explain in words what is meant by term acceleration. I have already mentioned acceleration is the rate of change of velocity, so you're gonna write that it is equal to the rate of change of velocity is known as acceleration. Okay, moving to its other part is B, and it's plotting of graph. I hope you can see the graph. Okay, the question is the car travels at 13 meter per second from t is equal to 3.2 to 12 seconds. Plot the speed time graph for the car for the time t is equal to 0 and t is equal to 12 seconds. So we're gonna need to plot this graph. We already calculated that for the first 3.2 second, which was mentioned in the first part, the velocity was 13 meter per second. So we're gonna calculate from here. This is 2.4, 2.8, and this would be 3.2. So we're gonna rise 3.2 to the value of 13. So this would be the value of 13. This. So we're gonna plot this line. 0 to 13. This would be like that. Now we know that from the car travel this from this point t is equal to, it travels to 13 meter per second, and it means that its velocity is not changing up to 12 seconds. So 12 seconds is here, 12 seconds is here. So we're gonna extend this line to this point, or matching these 2 points. So this is how we have plotted the graph. Moving to its other part, determine the distance traveled by the car between t is equal to 0 and t is equal to 3.2. Means that we need to calculate this distance during these interval of time, 3.2 seconds. So we already know that we can calculate from the speed time graph the distance by calculating the area of the graph. the area of this graph is for this part is of triangle. So we're going to use the formula for the distance is equal to area under the graph, and this would be 1/2 base into height, area of triangle. Base for this part is 3.2 and height we know that it is of 13. After simplifying this value to the calculator, the answer would be 21 meter. So we're gonna write our answer over here, 21 meter. Next part, moving to the C part, the speed the car decelerates from 13 meter per second at a constant deceleration. The mass of the car is 1350 kg. The car travels 13 meter in 2 seconds as it decelerates. Show that work done by the car as it decelerates to approximately 1.1 into 10 raised to power 5 joules. So we know that we have to show this value. This is the work done that is given, and we know the formula for the work done is W is equal to force into distance. So we just need to calculate the force because distance is given, that is 13 meter. We're going to calculate the force by using this formula, F is equal to MA. The mass is given, the mass is 1350, but acceleration is not given. So we're going to calculate acceleration by using the formula of change in velocity over time. So the change in velocity is actually equal to 0 minus 13 and the time difference is 2. So this is how we're going to get change in velocity over time, the acceleration. Ignoring the negative sign, we have the value of 8775. Why we ignore the negative sign? Because negative sign is only for the direction, so we need here the quantity, so that's why we have ignored the value negative sign. Okay, we're gonna put this value of force over here, 8775, and okay, we already know the distance is 13. So we're gonna multiply that 8775 into 13. It would be 114075. We're gonna write in the standard form. It would be like that. We need to write this into two significant figures. So that's why this has shown and this has proven. Our answer is same. Okay, moving to its D part. On another day, the car in C travels longer distance while it decelerates from 13 meter per second to 0. Now it means that car is taking travels a longer distance, but it decelerates from 13 to 0. The deceleration is constant. Suggest and explain what causes the stopping distance to increase. We know that stopping distance could be increased by many reasons, but we're gonna write any reason. We would write simply it was a rainy day. Because of rainy day, the road become more slippery, the friction force become less because of the slipping between the rods of the tires, and harder to apply the brake, and it would take more time to stop. So that's why stopping distance would increase during the raining days. So we're gonna write this answer like that. Hopefully you get the understanding of this question. This was the simple application of friction in the rain and how it reduces. Moving to the next part. Next part is question number 2. Figure 2.1 shows an electric tumble dryer used to dry wet clothes. Okay, this is the diagram explaining the function of this diagram. Now part A, hot air blows into the drum. You can see that drum and it rotates. Hot air when blows, drum rotates the clothes, and it the wet particles then goes into the condenser, then it goes back into the hot air, and this process cycles until we get the water over here, and the clothes become dry. The air goes into the water vapor from the close and then leaves the drum. The moist air enters the condenser. Cool air leaves the condenser, passes through the heating element and enters the drum again. State the process by which the hot air removes water from the wet close. So we're gonna need to identify the process, and this process is known as evaporation. This is the simple answer, in which air particles a hot air removes the water from the wet close. So evaporation is our answer. Moving to its second part, the air is cooled as it passes through the condenser during and describe and explain one other way in which air leaving the condenser is different from air entering the condenser. So we're gonna write any we can write that air is drier. Air is drier, carries no humidity. Okay. Explanation is the water vapor has condensed. The water vapor has condensed. Okay, moving to its B part. During hopefully you can see. Okay, the drum of the tumble dryer rotates, lifting up the wet clothes, which then fall down through the hot air. Name the force that causes the clothes to fall down. Obviously falling down is a gravitational force or gravity. So you're gonna write that it would be a gravitational force. Next part is when the drum rotates too fast, the cloth remains in the contact with the wall of the drum. State the direction of the resultant force on the cloth during the circular motion. We know that force is perpendicular to its motion. Whenever a particle is moving in the circle, then the force direction of the force will be tangent to it. So we're gonna write that force is perpendicular to its motion. Force is perpendicular to its motion. Now moving to last part of this question. Suggest why using a clothes line to dry clothes in the open air is better to the environment than using an electric tumble dryer. Because it is a natural process and we do not need the electrical power to dryer, and we're gonna save or preserve the energy. So we're gonna write that it is a renewable source. No energy is required for electricity generation, and environment would be healthier and safer through it. Okay, moving to question number 3. Question number 3. Okay. A balloon of mass 15 gram is glued to a straw. The straw is like that. The straw is threaded onto a horizontal string. Okay, the straw as shown in the figure 3.1. The balloon is filled with air and then the air is released. Horizontal string direction of the motion of the balloon, hollow straw fixed to balloon and balloon. As the air leaves the balloon experiences a force. The balloon accelerates from the rest until it reaches to a constant speed. Whenever the speed is constant, the resultant force is 0. You must remember that. It then travels 0.67 meter in 0.18 second at the constant speed. Explain in words what is meant by the term impulse. So the term impulse is the product of force into time. So you're gonna write that force into time is equal to impulse. Next part, calculate the resultant impulse on the balloon while it accelerates. Okay, you need to know the mass of the balloon is 15 grams, so we're gonna use that here. Calculate the resultant force. Okay, calculate the resultant impulse on the balloon while it is accelerating. So we know that resultant impulse is equal to change in momentum, delta p. Delta p means change in momentum, and change in momentum has a formula of mv minus mu. So we know the mass is in 15 gram of balloon. We're gonna convert into the kg. That would be 0.015 kg by dividing it by 1000. Okay, but we do not know the velocity of that balloon, so first we need to calculate the velocity for it. We're gonna calculate velocity here. V is equal to question mark distance we have been given by, that is 0.67 meter. Time is also given, that is equal to 0.18 second. You can see that, and we know the formula is d by t. So distance is 0.67, 0.18. We're gonna get the velocity, that is equal to 3.72 meter per second. So we're gonna write the values over here. Mass is equal to 0.015. Velocity we have just calculated 3.72. Then the mass is 0.015, and it comes into the rest, so the velocity would be 0. So we're gonna multiply these two values. We're gonna get the answer 0.056 Newton second. This is the value of impulse. Unit of impulse is very important. You should know that it is Newton second, because it is the product of force into time. Next part of this question is explain how momentum is conserved as the balloon accelerates. Momentum is conserved when air is released from the balloon and it moves in the opposite direction, like air release in this direction and balloons move in that direction. So momentum remains conserved. Moving to its B part. B part is figure 3.2 show the direction of the two forces acting on different balloon as it moves. 0.40 Newton and downward force is 0.74 Newton. Determine the magnitude and direction of the resultant force on the balloon. Okay, first we're gonna draw like that. You can take scale and by suitable scale you can calculate from the diagram, or you can calculate by simply calculating through Pythagoras theorem. So I'm gonna apply Pythagoras theorem here. 0.4 Newton and 0.74 Newton. I'm not drawing it to the scale, so the resultant force would be like that, meeting the first vector to the last. We need to calculate this angle, and we need to calculate the value of resultant force. By applying the Pythagoras theorem, that is equal to r square is equal to 0.4 square plus 0.74 square. Taking the square root, 0.4 square plus 0.74 square. After solving it, we're gonna get the value of resultant force, that is equal to 0.84 Newton. Now we need to calculate the angle. We're gonna calculate the angle by simple trigonometry ratio. Tangent theta is equal to perpendicular over hypotenuse. Perpendicular here is 0.74 and the base is 0.4. We're gonna take the tangent inverse of 0.74 and dividing by 0.4. So our answer would be 62 degree. Our answer would be 62 degree. So we're gonna write our answer over here, 0.84 Newton and 62 degree. Hopefully you get the understanding of this question. This question was simple but carrying 4 easy marks. Moving to the question number 4. Question number 4 is figure 4.1 shows a bottle part filled with water. The air inside the bottle is at the same pressure the air outside the bottle. The pressure inside and outside the same. The bottle and its contents are at the room temperature. The temperature of the bottle and its contents are increased. Explain in terms of particle how air pressure inside the bottle changes as the temperature increases. Okay, this is a simple explanation. Whenever the temperature increases, the particle gets more energy. It means their collision chances is increased because their vibration they vibrate more. When their vibration increases, their chances to collision between the particles increases. So the frequent collision between the particles increase. That's why the pressure inside the bottle is also increased. So we're gonna write that when temperature increases, particles gain kinetic energy. They will vibrate more. So frequent collision in bottle, greater force per unit area. Therefore pressure increases. Next part is the lid is removed from the bottle. State and explain how the air pressure inside the bottle changes. When the lid is removed, pressure is decreased. So we're gonna write that pressure decreases. Why it decreases? Because particles leave the bottle. So now inside the bottle, particles have less concentration. So because particles leaves the bottle. Moving to the next part, the mass of water, the mass of water in the bottle is 0.18 kg. The specific heat capacity of water is 4200 joule per kilogram degrees Celsius. Calculate the thermal energy needed to release the temperature of water by 20 degrees Celsius. So we're gonna calculate the value of thermal energy. Formula of thermal energy is like that. Energy, or you're gonna show it by Q, is equal to mc delta theta. We have been provided with the value of m. Value of m is 0.18 kg. You can see over here, and the value of c is also given, that is equal to 4200. And the change in temperature is the increase in temperature, that is also given, which is 20 degrees Celsius. So after multiplying it, we're gonna get that 1.5 into 10 raised to power 4 joules. So we're gonna write our answer 1.5 into 10 raised to power 4 joules. Moving to a C part, another plastic bottle is filled to the top with the water. The height of the bottle is 40 centimeter. The density of the water is 1 into 10 raised to power 3 kilogram per meter cube. Calculate the pressure difference between the top and the bottom of the water. So we're gonna use the formula pressure is equal to rho GH. Pressure is equal to rho GH. We know that density is given, that is equal to 1 into 10 raised to power 3 kilogram per meter cube, and height is also given, that is equal to 40 centimeter. We're gonna convert it into the meter, so it would be 0.4 meter after dividing it by 100. So we're gonna substitute those values in this formula. Density is equal to 1 into 10 raised to power 3. We had provided with the value of g at the start of the question paper, that was 9.8, and the height is 0.4. After multiplying it, we're gonna get 3920 0 Pascal. But we need to give our answer in two significant figures. That's why we're going to round it off to 3900 Pascal. So this is how we have done question number 4. Moving to question number 5. Question number 5 is figure 5.1. 5.1 shows a road junction. Okay, a moving car and a stationary truck. The road has high walls. It means the road has high walls. It cannot see that car on each side. Okay. The requirement is the driver on the truck is at position X. We're gonna see that where is position X. This is position X. Okay. On figure 5. The car moves around the corner. On figure 5.1, label a point Y on the road where the truck driver first sees the car. Okay. We know that car gonna move like that. And when our driver gonna see like driver is at X, so suppose that his eyes are here, so we're gonna say that driver gonna see at this position the car moving. Okay. Moving to its other part. Next part is a plane mirror is placed. You can see that a plane mirror is placed at the road junction. Okay. A plane mirror is placed on at the road junction as shown in the figure 5.2. Show how the mirror, okay, you can see the requirement. Show how the mirror allows the driver of the truck to see the car when it is at the position shown in the figure 5.2. So first we need to draw the line of sight of the driver. The line of sight of the driver would be like that. So it is meeting at the mirror. So this point we're gonna draw the normal to the mirror, and this angle and this angle would be equal. So we're gonna calculate this. We're gonna draw the same angle over here. So this would be like that. Then the object of the car, I'm gonna write that angle I is equal to angle R. This is angle I and this is angle R. So this is how we have shown how plane mirror could help the driver to see the car first. Okay, moving to its C part. C part is the truck driver wears spectacles to correct long sightedness. Figure 5.3 shows how a blurred image of the object is on the retina, and any effect of cornea on the rays of the light can be ignored. You can see that the retina, the image is not formed. Image is formed beyond the retina. So we need to converge those lines. For converging those rays of light, we need to use convex lens to correct this error. So adding a suitable lens, it would be convex lens. So I have already plotted this. So we're gonna plot, these lines were given, these three lines. So I have plotted over here convex lens converge these rays of light into retina. So this part would be like that. You're gonna draw the straight line and you're gonna bend it to this and bend it to this. So this is how you have corrected the defect of the eye by convex lens. Convex lens is used for the converging of rays of light. And if it was the reverse case, then we have to use concave lens, and it was the case of diverging lens. Now moving to question number 6. Question number 6 is from the topic of electricity. Okay. Figure 6.1 shows the circuit diagram for a flashlight that is tall. The electron motive force is EMF of the battery, that is 4.5 volt. The circuit contains a 60 ohm fixed resistor. The current in the light emitting diode, that is equal to 0.020 ampere. Calculate the potential difference across the LED. So we're going to calculate the potential difference across the LED. We know that there would be two potential, that would be total potential will be equal to LED plus potential across resistor. So first we need to calculate the potential difference across LED. So we know that the total potential is equal to value this, that is equal to 4.5, but we need to calculate this VL for LED, but we are not provided with VR. So first we need to calculate VR as well. Potential across the resistor, this would be calculated through the Ohm's law. IR current is given, that is equal to 0.02 ampere, and resistance is also given, that is equal to 60 ohms. So we're gonna get the answer, that is equal to 1.2 volts. So we're gonna use this plus 1.2 volt. We're gonna subtract 4.5 minus 1.2. we're gonna get that 3.3 volts. So the potential across the LED resistor would be 3.3 volts. Explain why LED does not light up if the battery is reversed. If the battery is reversed, their diode function will not function. So it will not allow the current to pass through it. So we're gonna write that LED allow current to flow only in one direction. LED allow the current to flow only in one direction. Moving to C part. The C part is the chemical energy stored in the battery is equal to 1 the chemical energy stored in the battery is 1050 joules. Show that the flashlight operates for approximately 3 hours. So we're gonna prove this value, that the time taken is for the flash is 3 hours. So we have been provided with the energy value, that is equal to 1050 joules. We're gonna show that the answer for the time should be 3 hours. T is equal to 3. V is equal to 4.5 volt. We have been provided, and the value of the current is equal to 0.02 ampere. This was the data we have already used. The formula for the energy is equal to power into time, or power is equal to P by T. So we have calculated this formula, and value of power we're gonna use that VI into T. We have been provided with the value of energy, that is equal to 1040, and the value of V is 4.5, and the value of I is 0.02. But we do not put the value of T, because we need to calculate, we need to show the value of T, which is equal to 3 hours. Okay. Okay, we're gonna multiply these two values and calculate 4.50 multiplied by 0.2 and divide it by 1050. We're gonna get the value is 11666.67 seconds. but we need to convert into the hours, so we're gonna divide it by 3600. After dividing it by 3600, we're gonna get 3.2 hours, which is approximately equal to 3 hours. So we're gonna write our answer as 3 hours. So this was the simple question of energy power, but it also uses the other relations. Moving to next part, calculate the total charge that flows current the LED in 3600 seconds. So we know that the formula for the charges is Q is equal to I into T. We have been provided with the value of I, that is equal to 0.02. We have just for the time 3600 seconds, we're gonna multiply it by 3600. After multiplying by 3600, we're gonna get the answer, that is 72 coulombs. So we're gonna write over here 72 coulomb. Moving to question number 7. Question number 7 is from the topic of electromagnetic radiation. Figure 7.1 shows uses of electromagnetic radiation, okay, and the different regions of the electromagnetic spectrum. Bluetooth handset is used, falls in the radio wave spectrum, and thermal imaging would fall into the infrared. So we're gonna label it like that, thermal energy into infrared. Photography of people faces. Photography of people faces is gonna use the visible light, and sterilizing medical equipment, we will use gamma rays for sterilizing. So we're gonna label cross match like that. So this is how we have completed this question. Now moving to A part is done. State the speed of electromagnetic waves in vacuum. We're gonna use the speed of light, that is equal to 3 into 10 raised to power 8 meter per second. Moving to this other part, a Bluetooth handset can be used to listen to the music on mobile cell phone without the need for wires to connect the handset to the phone. The hardest use the frequency in the range is 2.4 till 2.48 gigahertz. Giga means 10 raised to power 9. I'm going to write here, giga means 10 raised to power 9. Calculate the wavelength of the radio waves and the frequency is the middle of the frequency range. So we're gonna take the value middle, which is equal to 2.4 plus 2.48 divided by 2, and the answer would be 2.44. And the formula is V is equal to F lambda. So we're gonna calculate the value for the lambda. It would be, speed is 3 into 10 to the power 8, and the frequency is the middle is value, that is 2.44, but it is in the gigahertz, so we're gonna convert into the hertz. The giga equal to 10 raised to power 9, so we're gonna use 10 raised to power 9, and we need to calculate the value of lambda, so we're gonna write lambda like that. So lambda would be equal to this 3 into 10 raised to power 8 divided by 2.44 into 10 raised to power 9. So the value of lambda would be 0.12 meter. 0.12 meter. So we're gonna write this answer 0.12 meter over here. Next part is suggest why a Bluetooth headset only works well over short distances. Why it works well for the short distances? Because radio waves loses energy. So we're gonna write that radio waves loses energy when they have to travel more. So radio waves loses energy, so it only used for the short distances. Moving to its next part, moving Next question, question number 8. Question number 8 is from the topic of atomic physics or radiation activity. The isotope of uranium is 235 is represented by uranium 235 92. State what the number 92 and 235 represent in the symbol. 92 is the proton number. Or you can write it is atomic number, and 235 is nucleon number, or you can write it is a atomic mass number. So uranium 235 is a fuel that is used in the nuclear reactor. State the process by which energy is released from uranium 235 in a nuclear reactor. So state the process. So we need to only write the process. It is the process of nuclear fission, when the heavy nuclide split up into the smaller nucleotide. So it is a nuclear fission reaction. A nucleotide equation for this process is given. Uranium by the attack of neutron. This is the example of atomic fission reaction or nuclear fission reaction. It is split up into xenon and strontium, and you can see that 2 neutrons is emitted. Describe the mass and energy changes that take place during this process in a nuclear reactor. Nucleus is converted into uranium was unstable nucleus, and it is converted into 2 stable nucleotides. You can see that xenon and strontium. But their masses are smaller. So we're gonna write that nucleus is converted to more stable nuclei with smaller mass, and the mass difference is converted as energy difference. Okay, describe how thermal energy from the nuclear reaction is used to generate electricity in a power station. It is used for making steam. And what steam do? Steam helps the turbine to move and to rotate, and it produces kinetic energy through its generator rotates and electricity is produced. So we're gonna write that it is used for making steam, drives turbine to rotate, connected to a generator to convert kinetic energy into electricity. Moving to the next part, state one advantage and one disadvantage of using nuclear fuel in a power station instead of using fossil fuel. So the advantage is huge amount of energy, no greenhouse is gas, it creates low pollution. Disadvantage is that danger of radiation from nuclear waste. So the radiation waste could be very damaging for the health issue. So we're gonna write in this disadvantage. Moving to question number 9. Question number 9 is from this space physics or astronomy. Okay, this is easy question. Table 9.1 gives information about the 3 planets in the solar system. Okay, state the Earth, Jupiter and Uranus. The mass is given 5.97, and the distance is also given. So you're gonna name this, state the name of planet by the distance. So you know that its distance is from the sun is less than the Earth, and it means the planet come before the Earth. So it is, we're gonna write the name of the planet as Venus over here. Now next part is describe the relationship shown in the table 9 between the mass of planet and the gravitation field strength. The mass of planet, you can see the Earth has this, and the gravitation field is this. When the mass is greater, the gravitation field strength also increases. When the mass decreases, the gravitation field strength is also decreased. So we're gonna write that larger the mass of the planet, larger the gravitation field strength. So I'm gonna write that larger the mass of the planets, larger will be the gravitational field or gravity, or you can write gravitation field strength. So mass is directly proportional to the value of the gravity. Explain why the distance from the sun in table 9.1 is an average value. Because it orbits in an elliptical part, not circular part. So that's why we need to record the we need to take the average. So that's why I'm gonna write that the orbit is elliptical, not circular. So we need to take the average for it. Next part is show that the average orbital speed of the earth is approximately 30 km per second. So we're gonna need to prove that. We know the formula is speed is distance over time, and distance is equal to circumference 2 pi r over time. The value of 2 and pi, we're gonna write the value pi, and the radius we can see from the question, from the table, that is equal to 149.6 into 10 to the power 6. So we're gonna write that 149.6 into 10 to the power 6 and dividing by time 365 days, converting into the second, multiply by 24, multiply by 16, multiply by 60. So it converted into, so the answer will be 29.81 kilometer per second. So when we gonna round it off to 30 kilometer per second, this is how we have shown the speed of the earth. Moving to the last question, question number 10. Question number 10 is complete the sentence about the life cycle of the stars. Protostars are formed from the cloud of dust and gas. So we're gonna write that they are formed from the cloud of dust and gas. From clouds of dust and gas. Okay, moving to next part. A protostar becomes a stable star when inward force of gravitational attraction, when inward force of gravitational attraction is balanced by outward force due to high temperature. The initial fuel used to power nuclear reaction in the star is called hydration. So I'm gonna write over here hydration. Last part is stars that are approximately the same size as the sun become red giant star, which then form a dash, a planetary nebula. Planetary nebula. So we're gonna write planetary nebula over here with the white dwarf star at its center. So this is how we have done and completed the paper. Hopefully you get the understanding of this paper. If you do have any queries related to this paper, you can ask in the comment section, and if you do find this helpful, do like the video and share with your fellows, and don't forget to subscribe this channel. Thank you for watching this video. Allah Hafiz.